Hello, welcome to Engineers Mindset. So let's say we are given to determine the supports at points B and point D for the beam shown. Okay, so this beam actually carries 2-point loads at point A and point B, and then carries a uniformly varying load between point C and point D. Alright, so let's start with free body diagram F, B, D. Alright, so you bring back the beam. At point A, we have a downward force of 5 kilonewtons. So we have 5 kilonewtons at point A. Meanwhile, at point B, we have a pin. And for a pin support, I've already said we have two reactions. One vertical to the point. So we have R, BY, and then one horizontal to the point as well. So we have R, BX at point B. Okay, between point C and point D, we have a uniformly varying load. Alright. Now, I said in the introduction video that to convert the UVL to a point load, simply take the area of the shape. Since this shape is triangular, the point load becomes the area of a triangle. So point load is actually half base. The base is the length of the UVL, which is 3 meters. So half base times height. The height is the maximum load or maximum intensity of the UVL load, which is given as 5 kilonewtons per meter. So you simply have half base times height as 1/2 times 3 times 5, and this is actually going to be about 7.5 kilonewtons. Okay, so that becomes the point load of the uniformly varying load. And I also said that to place this point load on the beam, you place it at 1/3 from the base, 1/3 of the length from the base, or 2/3 of the length from the tip. So if you check from the base, 1/3 of the length is simply 1/3 times the length is 3 meters. This actually was 3/3, and that's 1 meter. So from the base, that is from point D, you place it at 1 meter of the length. The total length is 3 meters. So 1 meter away from 3 meters is actually was somewhere around there. So this is 7.5 kilonewtons. So from the base, it's 1 meter. Then it actually was 2/3 of the length from the tip, so which means the remaining balance is what? The remaining length is actually 2 meters. Okay, so you have this. Or if you also want to check it out from the tip, place it at 2/3 of the length. The length is 3. So 3 times 3, you're left with what? 2 meters from the tip. That's what you can see. 2 meters or 1 meter from the base. Okay? Alright, so after converting that to the point load and placing it on the beam, at point G already we have a ruler. This under way, a ruler can also be depicted. You can also symbolize the ruler by this, okay? And for ruler support, we just have one reaction. So this is point D. We have one reaction, also normal to the surface. So this is the arrow dy. And then finally at point A, we have 10 kilonewtons force acting downwards. So we have 10 kilonewtons force. The distance is actually 2 meters. Okay, this is actually 1 meter, and this is actually 2 meters. So that's the free body diagram for that beam. So after the free body diagram, the next thing to do is to employ the equilibrium equation. So from static equilibrium law, you have that summation f of x is equal to 0. Also, summation f of y is equal to 0. So that simply means summation f of x, let's start with summation f of x equal to 0. It means look at the beam, sum all the forces acting on the x-axis and equate them to 0. So if you look at the beam now, the only force acting on the x-axis here is simply what? RBX. So that simply means now that implies that RBS is actually what? 0. Okay, so that's the first. The next is to employ the second equilibrium law. Summation f of y equals 0. So you have summation f of y equal to 0. So you consider upward forces, vertically upward force as positive, while vertically downward force as negative. So you have this. So all the forces that point vertically upwards, consider them to be positive, while all the forces that point vertically downwards, consider them to be negative. So we'll start from the beam. we have the 5 kilonewtons force at point A, and this force is acting downwards. So the force is negative. You have minus 5. Moving down to point B, we have RBY pointing upwards. So it's positive. Plus RBY. Moving down to point, this point between C and D, we have 7.5 kilonewtons force acting downwards. So it's negative. Minus 7.5 kilonewtons. And then finally, at point D, we have RBY acting upwards, so it's also positive, plus RBY. Okay. And then finally, at point E, we have 10 kilonewtons force acting downwards, so it's negative, minus 10 kilonewtons. And all of this is equal to 0. Alright, so we connect like this now. We have RBY. Okay, so we connect like this now. We have RBY. Let's bring plus RBY together. Okay. Now minus 5, minus 7.5, and minus 10 equal to 0. So RBY plus RBY minus 5 minus 7.5 is minus 12.5 minus 10 is minus 22.5, and that's equal to 0. So we can send minus 22.5 over to this side of the equation. Negative sign plus and equal to sign becomes positive. So you simply have RBY plus RBY to be equal to 22.5. So we call this equation 1. So I said that at this stage, since you have two unknowns in one equation, the next thing to do is to simply what? Take moment about the point where you have numerous of forces. So always take note of that. You take moment about the point where you have numerous of forces so that the effect of the moment of those forces becomes nullified, that becomes 0. So we take moment at B. So summation of moment at point B equals 0. Assume clockwise moment to be positive and anti-clockwise moment to be negative. So we are taking moment at point B because point B have two reactions, RBS and RBY. So we have numerous of force at point B. So we take moment of force about that point because moment is force and distance. So the effect of this force and this force, the moment of this force and this force about point B becomes 0 because there is no distance between this force and the point B. So the distance is simply what? 0. So it becomes RBY times 0, RBS times 0. So the moment of those forces at that point becomes 0. So that's why you take moment about a point where you have lots of forces. Always take moment about that point. So if we do that, we now have to take moment of every other force about point B. So the moment of this force about point B, this force is acting downwards, it will move all the way from this side to get to point B. So which goes clockwise direction, right? Okay, the wind goes anti-clockwise, so it's negative. This is direction, so we said anti-clockwise is negative. So the moment of this force about point B is actually negative because it's anti-clockwise direction. So therefore, our moment is force by the distance it takes this force to get to point B. The distance it takes this force to get to point B simply was 2 meters. So you simply have minus 5, minus because it gives us negative moment times distance 2 meters to point B. So you have that. The next moment to take is the moment of this 7.5 kilonewtons force about point B. This force is also pointing downward, but it will go all the way from this side to get to point B. So which means it's clockwise in our direction. Positive. It's clockwise and it's positive. So it moves all the way from this point to get to point B. Distance it takes this force to get to point B is simply 2 meters plus 1 meter, that's 3 meters. And it's positive because it is clockwise. So you simply have plus 7.5 times 3 meters. Also, we have RBY. RBY is pointing upwards. So the moment of this force will go in this direction. Okay, it's pointing upwards, so it goes in this direction. So it's actually anti-clockwise. So it's negative. It's anti-clockwise. So the moment of this force is going anti-clockwise, so it's negative about point B. And distance it takes this force to get to point B is simply 1 plus 2, which is 3, plus 1, that's 4. So you simply have minus R dy times 4. And then finally, you have the tension resistance force acting downwards. The moment of this force about point B will go in this direction, which is what clockwise to get to point B. So it's positive. The moment of this force about point B is clockwise, so it's positive. And distance it takes this force to get to point B is simply 2 meters plus 1 3 plus 2 5 plus 1 6. So total distance it takes this force to get to point B is actually what 6 meters. And the force it takes to this force it is clockwise, so it's positive. So you have plus 10 times 6, and that's equal to 0. So that's the entire force you have on that one, so it's equal to 0. So minus 5 times 2 is actually minus 10 plus 7.5 times 3 will give us 22.5. So we have 22.5 minus, this is actually minus 4 R dy. Okay, plus 10 times 6 is 60, and that's equal to 0. Okay, so let's collect back terms. We have minus 10 plus 22.5 plus 60 minus 4 R dy equals 0. Okay, alright, so this is 50 minus 22.5. Alright, so we'll have minus 10 minus plus 22.5 is actually 12.5 plus 60, that's 72.5. So you have 72.5 minus 4 R dy equals 0. So let's send minus 4 R dy over to this equation. Negative sign, positive sign, equal to sign becomes positive. So we have 72.5 equal to 4 R dy. So to make R dy subject, simply divide both sides by the coefficient of R dy, which is 4. So that's simply implies now that R dy is actually 72.5 divided by 4. And therefore, R dy is equal to 18.125 kilonewtons. So this becomes the reaction at the point D. So simply substitute R dy into equation 1. Okay, that's to obtain R dy. So from equation 1 we have that R dy, to obtain R dy. So we have R dy plus R dy equals to 2.5. So we simply have R dy plus, in case of R dy, we simply have 18.125, and that's equal to 22.5. So to obtain R dy, simply send plus R plus 18.125 over to this side. Positive sign, equal to sign becomes negative. So we have R dy is now equal to 22.5 minus 18.125. So therefore, R dy is now equal to, we have 4.375 kilonewtons. So this becomes the reaction at point B. Okay, so that's how you obtain the reactions at point B and the reactions at point D. Alright guys, in the next video, I'm going to do shear force analysis. I will do shear force analysis separate, and then I will do bending moment analysis separate. So in the next video, I will start shear force and bending moment analysis. Thanks guys. Please, I know you like this video. Don't fail to like, share, comment, and of course, subscribe to the channel and invite more friends for more subscribers. Thank you, and I will see you in the next video.